Welcome to Terminal Bash. Today we're going to be digging into the TypeScript handbook. So on the left here you can see we've got quite a bit of work ahead of us. I would say a prerequisite to getting into TypeScript would be to know some JavaScript, but you might be able to just learn it along the way. We'll find out. So we're going to dig in here. Got our chat up here on the right. All right, so basic types in TypeScript. So for programs to be useful, we need to be able to work with some of the simplest units of data. We've got numbers, strings, structures, which we'll get into, Boolean values, and the like. Very descriptive. In TypeScript, they support much the same types as you would expect in JavaScript, with convenient enumeration type thrown in to help things along. Make this a little bigger here. All right, so for Booleans, so most basic type, you're going to have true, false values come out of the Boolean. We've got the let keyword that we're familiar with. We define the variable, and then we've got this colon, and to the right of the colon, we're going to have the type. So I'm guessing this is going to be the pattern throughout, variable on the left, type on the right, then our equality to false. So I'm going to go ahead and in my editor here, so I'm in a TypeScript handbook folder here on my desktop, or in my home folder. We're going to make a directory for basic types. Bell Bronx, thanks for the follow. All right, so for basic types, we'll just go ahead and cd into there, and I'm just going to touch types.ts. So for the sake of muscle memory, I'm going to go ahead and type this out. So let is done Boolean, and this is going to be equal to false. Now, I'm not getting the type annotations that I expect from a TS, so what I'm going to do real quick, I use Vim as my editor, so I'm going to look up Vim TypeScript. So there's a few. Let's see. This one has 1,329 stars. And this one has 1,000. And we're going to ignore that one. Which one do we want? So let's look through it real quick. I don't even know how to pronounce that. Works as a client for TS server, which is an editor service bundled into TypeScript. So installing this gets your Vim the following features: completion, navigation, show locations, display a list of syntax and semantics. If you're using VS Code, you'll want to install some TypeScript support as well. So let's see what this does. Syntax highlighting, looks like mainly that. I might try this one out. Relevant plugins does not provide syntax highlighting or indentation. So we actually need both. We need TypeScript Vim, and we also need Tsukuyomi. Mostly. Okay, thanks. Tsukuyomi. All right, so I'm going to install both of these. I don't see why not. Especially because, whoops, remove that bookmark. Don't want that. This one, Tsukuyomi, references TypeScript Vim as an irrelevant plugin. So we've either got pathogen or just installing from Git. What I'm going to do is I'm going to try it with my plugin system. So I'm going to edit my Vim config, go down to line 60, and just paste this in. And plugin install. That'll go one by one through all my plugins until it finds this one, and it seems to have done the trick. So TypeScript Vim is in. We'll see this. And under the indenting section, this plugin includes a custom indenter based on Vim JavaScript's indenter. Works pretty well, but there are cases where it fails. If these bother you or want to use other indent settings, you can disable it. We'll leave it for now. This plugin contains compiler settings for make PRG, which to set make PRG, what is that? Make program? I'm not sure what make PRG is. Let's real quick, we will just man vim and look for make, is it MK? Make PRG. Not seeing it in there, so we'll ignore that for a moment. To run the compiler, enter make. This will run TSC against the latest saved version you currently have edited. You can enter the compiler. I'm gonna leave it for default for now. Although you can completely override this plugin's compiler settings with something in your vimrc where you can make PRG to whatever you want. Okay, we're gonna install this other plugin real quick. Yeah, we've already got that. So it wants us to download the zip or use our favorite plugin manager. Okay, so take this here, and back in one, we're just going to create a new plugin for this and plugin install. Okay, that's installed. How to use Control C, Control O in insert mode shows completions, or Control X, sorry, and Control O. I think I already have Control X bound to something. Nope, I don't. And Control O. Oop, I'm not sure what that did. So we're gonna quit out real quick and just go back into Vim types. Okay, so now we have our syntax highlighting. You'll see that Boolean is a lighter white and false is this green. So that's good. So if I were to say boo and Control X, doesn't look to be oh, Control O does what I wanted. So BO Control O. O Control O. Oh, I think it's both together. So if I do BO Control XO, Boolean. So it's a double toggle. So that's just something for me to know. All right, so we're good to go. I'm going to close these and we'll get back to working with TypeScript. All right, so I've got let is done defined. And then below here, we'll just cd into git and then TypeScript basic types. And I can do TSC, which you get by doing npm install -g TypeScript, I believe. So we'll go to typescript.com.org. If we go to download, right here is what you do. You can either do TypeScript install -g TypeScript or brew install TypeScript, which is what I did. So, and then we can compile with TSC and then the file that ends with .ts as the extension. So, all right. So let's do that real quick. I'm going to console log is done, and then TSC types. Didn't see our console log work. Test. Not sure why that's not working yet. We'll find out. So, moving on to numbers. So, as in JavaScript, all numbers in TypeScript are floating point values. These floating point numbers get the type number. In addition to hexadecimal and decimal literals, TypeScript also supports binary and octal literals introduced in ECMAScript 2015. So this is hexadecimal, binary, octal. All right, so first things first, I'm going to quit out of this. I'm just going to touch test.ts and vim test.ts and just console log hello world. I wonder if it's console log in TypeScript. tsc test.ts. So TypeScript tsc console. Okay, TypeScript console log doesn't work. That's what we're having. TSC is a compiler, not a REPL. You need to write TypeScript to compile it with TSC and execute it with Node. So, I see. Okay, so we'll remove rmrf test.everything. So what we see here is if I rmrf types.js, to get rid of that, we just see types.ts. And then if I edit types.ts and we tsc types.ts, that's going to make a JavaScript file called types.js. And if we open up types.js, we'll see that all this gets transpiled down to is JavaScript, and we lose the type safety. So the type safety is strictly for the compiler in TypeScript and for the developer convenience. So this is just a variable called isDone with false set, and then we are just console logging test plus isDone, which is false. So now if I node, because I've got Node.js, right? Node.js-v. 12.11.0 is the version of Node I have. So if I node types.js, then we see our test and false. Okay. So let's get back to it. So let's do some strings. Another fundamental part of creating programs with JavaScript is working with textual data. As in other languages, we use the type string to refer to the textual data types. Just like JavaScript, TypeScript also uses double quotes or single quotes surrounding string data. So this is going to be different than Rust or Go or a system level language where a single quote refers to runes. You can do either in TypeScript, and it's the same thing. You can also use template strings, which can span multiple lines and have embedded expressions. These strings are surrounded by the backtick character, and embedded expressions are in the form of $, curly brace, expression. We'll find out if we need those spaces on either side of the curly braces. So let's mess with those real quick. So let's get rid of this, and we'll just say let, what is it, full name type string, and you can see it turned a lighter white there, which means the type is accurate. And we want Bobbington. We're just going to follow this example to the T. He's going to be age is a number, 37, sentence is a string, and that's going to be in this text here. You can see that that's a template string. So we're going to do that. So 37 and then sentence. So let age as a number, let sentence as a string. Age is going to be 37, which ends up being a float, unfortunately. Just the way of the world in TypeScript and JavaScript. And the string will be not double quote, but backtick. Hello, my name is $, curly brace, and then we're going to say full name, and then end that backtick. And then we will console log sentence. So I'm not seeing any compilation errors, anything wrong. I wonder if I do this. Yeah, okay, perfect. So TypeScript is letting me know that I've got an error on line 4, column 15, and it says QF available cannot find name string A, right? So the moment that I fix this, that goes away, and we see our code will compile fine because the linter says so. So now we will tsc types dot TS, I'm going to do an ampersand to run another command right after that, and that's going to be node types.js. That'll be how we test this thing. So we see a little, what happened there? Why did we get SS? Okay, something weird had happened. I must have bumped the keyboard. So, hello, my name is Bob Bobbington. Now, what I'm curious about is if we need these spaces. So we'll run that again. And we don't. What we do need to determine is if this is the idiomatic way to include the spaces, which means the way the language would prefer you to write the code, or if it's just an example. Since it's in the TypeScript handbook, I'm going to leave them for now until I know better. Okay. And so you can also say, okay, this is multi-line, right? So because it's multi-line, because it's a string literal, we can basically just say, I will be age plus 1 next year. And run that. And then we see that he is currently 37, but he will be 38 next year. Or next month. We'll say next year. This sentence is equivalent to declaring sentence like so. So instead of having to do like these pluses to do string concatenation of full name, and then also have the /in or \in to have new lines, you can just use template literals and it's much cleaner. Okay. So let's talk about arrays. So you get every array has to have a type, I believe. You have two ways you can declare arrays. You can either use the short syntax, which is the double square brackets after the type, or you can have an array type with what is called a generic. So basically array can take any type in. Yeah, I believe that's true. Any type in. And instead of string here, we would say number. And that tells the array exactly what type it's going to be. We'll get into generics a little later. I'm not sure when. I'd have to zoom out to see. Okay, so those are the two ways. I'm going to use this first way. So we're going to say, we'll separate is done. We'll start adding some comments here. We'll say strings and string literals. This will be Booleans. And then we're just going to console log is done up there. We'll do another one down here. And this one is going to be arrays. Do they tell us what to call these? They don't. In the first, use elements followed by the curly bracket or the square brackets. So we'll just do that. All right. So let list of type number of an array equal to, and I assume it's just 1, 2, 3, 4, 5. Console log list and run it. Okay. And we see our list comes through exactly as expected. Okay. Now we'll talk about tuples. So tuple types allow you to express an array with a fixed number of elements whose types are known. So I don't think JavaScript has tuples. Let's find out. We'll go to MDN. Tuple. Yeah, they don't. So there are no tuples in JavaScript. So this is now a TypeScript specific feature. And an indication of that is that tuples allow you to have a fixed number with types that are known. And types are only in TypeScript. Or there's more strict adherence to types in TypeScript. For example, you may want to represent a value as a pair of string and number. So you can declare a tuple type, let x, colon, and then you can see it looks like array syntax, but there's only two types, and it's going to be what's on the left and what's on, so it's like the key and the value. So let's declare this. Tuples. And then we'll say let, and they're doing x. I'm just going to say my tuple. And that's going to be a type of, we'll say string and int. Or, I'm sorry, number in TypeScript. And a number is a floating point. So that's why I can't use int. It's not a valid type. All right, so then we can say, we could probably initialize this and we'll play with that here in a second. So my tuple is equal to test 10. And then we will console log my tuple. Console.log. Okay, so we see here, and I'm going to start being more clear. Tuples, arrays, strings, and then Boolean. Now it's more clear. And also in tuples, let's do another tuple. And we will say it's going to be my tuple 2. And instead of ending it here, we're just going to say is equal to another test. And then say 20. Compiler, or the linter, seems happy with that. We run it and we can see that it works. No, I didn't include it in here. Now it'll work. So there you have it. And just for clarity, let's look at types.js and see what's actually happening. So this is the JavaScript that gets transpiled from the TypeScript. And in tuples, you can see that all we're doing, like this is just a var declaration of my tuple, which is interesting that it's not let. I guess they're keeping it reassignable. There's probably a keyword to handle that. My tuple is equal to just an array, test and 10 in there. So again, tuples are nothing special. They're transpiling down into JavaScript arrays. Just a moment. Okay. So now that we've determined that, we're just going to give ourselves a little more space here on the editor. And we're going to move on from tuples. Okay, so, or into tuples. When accessing an element with a known index, the correct type is retrieved. Okay, so let's mess with that. So we'll console log. Let's delete to my tuple, and we'll just delete to the end here and go by an index 0 and see what that gets us. Oop. Okay, so we see test on that, and if we reference my tuple index 1, see what we get. Right, so nothing unexpected there. That's just array index 0 and 1, which is the key and the value, essentially. And they express an array with a fixed number of elements whose types are known. So it's not even key index. So like, for example, let's create another tuple. And we'll call that tuple 3. And then we want it to have a string, a number, and a Boolean. And we'll say additional, what do we call them, elements? Fixed number of elements. 20, and this one's going to be true, right? If we were to change this to 20, we'd get a error right off the bat saying number is not assignable to type bool. When we put true, all that goes away. All right, so now we can see my tuple 3, and if we run this, we can see that we've got an additional true value here in this last tuple. So I think that's tuples in general. Accessing an element outside the set of known indices will fail with an error. Property 3 does not exist on type string number. Error property 5 does not exist. So, and you can catch those errors, I believe. We'll do that. I guess we could do that right now. So let error tuple of a string and a string, and that's going to equal error example. This should error, and then we'll say try, and then a catch, and we'll learn about these a little later. This is a JavaScript thing. If we try to console log error tuple 012, which is out of range, we already get an error. It says cannot find name console log. Should probably put a dot in there. But we also see that tuple type string of length 2 and then it says has no element at index 2, right? So our linter is catching this error early, but let's say we want to catch it. I need to look up the syntax for try catch real quick. So JavaScript ES or MDN try catch. So MDN is the Mozilla Development Network, developer network. We want to use this for all our documentation. We can see catch opens up like a function and takes in a variable, an argument, that we are going to call error. We could call it anything. We're going to call it error. And we're just going to console log the error. Okay. So again, our linter is letting us know, but we can go ahead and compile this, and we'll see. My assumption is that this will not compile, but let's find out. Perfect. So we could probably turn down the sensitivity on TypeScript, but this is exactly what you want it to do. And this is the sort of type safety that you get with TypeScript that you wouldn't get with JavaScript. And it's telling us, fatal or one error found, and it's not going to compile. Now, if we were to TypeScript ignore, what is this called? No element error. Ability to overpower TypeScript and ignore specific error by developer. We'll go way to the bottom. We could do this, I guess. TSLint disabled. So let's see if this works. So up here, we would basically put this here and see what happens. And it doesn't look to do what it should. Arriving here, looking to suppress error. Anyway, as of May 19th, 2018, the answer seems to be no. And you know what? I'm okay with that. I like it to not even allow us to do something like this. So we're going to get rid of all this code for the error tuple, get this back in working order, and transpile it to JavaScript, and we're working again. All right, so now that we've talked about tuples, we're going to move on to enums. So enums are a helpful addition to the standard set of data types from JavaScript. As in languages like C#, an enum is a way of giving more friendly names to a set of numeric values. Right. So we're going to create an enum for red, green, blue, and let C color equals color.green. And so by default, enums start with 0 and increase incrementally. So if you start with red is equal to 1, then green is 2, and blue is 3. And that's how enums work in TypeScript. So let's mess with that. Enums. Let my enum, and that's going to be not a type. Oh, and we don't even, we have a keyword here. Enum as a keyword. And then red, green, blue. And that passes linting. And then we will let color of my enum, I think. No, color of what? Color. Oh, my enum has a name, so it is my enum. So I'm going to change that real quick just to color. Looks like it might be idiomatic to have enums with a capital letter, like Pascal case. So we're going to do color. And then we're going to have color here equal to color.blue. Okay, and then we will console log enum, and that will be color. Transpile and run, and we see enum 2 comes up, right? So that is, by default, red is 0, green is 1, blue is 2, and that's why we see 2 down here. So it is just like doing a mapping, like a hash map to the word to the number. I believe that's all they do. You can manually set them all if you want. Think of this being good for things like error codes, right? So say that we've got an enum called response codes, right? And we want OK to be 200. And we want, not found to be 404. And we want redirect to be 301. And then we can just say let response code. It's going to be a response code. And it's going to be response code OK. And then we can just delete 2. We'll say response like that. Compile. And there we can say, okay, response 200. So if you're like returning from a function, you want to return response codes dot OK. And that would, it's throwing a fit because I don't actually have a function. But if I did my func is equal to that function. Cannot find let my func. Yeah. Okay. And then if we were to just call function call would just be my func. Call it. It returns 200, and thus this should have 200 twice. Yeah. So we've got a function call that returns 200, and it just becomes readable. And enums are helpful for that. Okay. So that covers enums, and now we're going to talk about the any type. So we may need to describe the type of variables that we do not know when we are writing an application. Okay. These values come from dynamic content, e.g. from the user or third-party library. In these cases, we want to opt out of type checking and let the values pass through compile time checks. To do so, we label these with any type. So one thing you can think about is not all function calls to your code are going to come from TypeScript. And what that means is you can have another JavaScript library that calls to your TypeScript library, and they're going to pass in a variable that can be either a string, a number, a Boolean, or undefined or something. It can be any of those types. And any is there to allow that in, so then you can handle it in that function and then return a strict type from it. Not ideal, but when dealing with JavaScript, you need to be able to handle any type coming into a function. So let's handle that. Any. So we're going to have a not sure variable with an any type, and maybe a string instead, not sure false. All of these will be okay. So let not sure equal any, or be a type of any, and for starts it'll be 4. And then not sure is going to be a string now, and then the last thing will be a Boolean. So not sure is equal to a Boolean is equal to false. Okay, so we'll just console log in between all of these, and we're just going to console log not sure. And we're going to say, first we'll console log any types allowed. Not sure, not sure, not sure. And we'll run that. And now we can see any types allowed here. Let's do an empty line above there. Okay. Any types allowed for a string now and false, right? And if this were number, that would not pass the linter, and the linter would give us errors about the type. But since we have any, everything is fine. All right, the any type is a powerful way to work with existing JavaScript, allowing you to gradually opt in and opt out of type checking during compilation. You might expect object to play a similar role as it does in other languages. However, variables of type object only allow you to assign any value to them. You can't call arbitrary methods on them, even ones that actually exist. So, not sure any for, not sure if it exists. Okay, if it exists, might exist at runtime. To fixed, okay, to fix exists, but the compiler doesn't check. Now, if we have an object of for, we say to fix. Well, to fix doesn't exist on type object, and it will catch that at compile time, which makes sense. So the any type is also handy if you know some part of the type, but perhaps not all of it. So you can say any array. So you can have 1, true, free, and then you can set 1, which would be true, to 100. And you can sort of mix up the types. Personally, probably not a big fan of any, but I'm sure it has its place. So void is like, this is the next type that we're working with. Void is a little like the opposite of any. The absence of having a type, any type at all. You may commonly see this as the return type of functions that do not return a value. Okay, yeah. So basically, if you have a function, void. So let's say we have a function. So we'll do function expression. Let void function equal a function, and it's going to return void, right? It looks to be idiomatic not to have a space before the colon, so I'm going to remove my space here. And we will say console log doesn't return any type. Right? So it's doing work as a function. It's just not returning a type. Now we're going to have a non-void function. And that is going to return true. It's going to return a Boolean, right? Now, we didn't need to specify Boolean here, but we could. We can specify Boolean, and that works fine. But if we specify number, we're going to run against a linting error saying, hey, true is not assignable to number, right? It has to be a Boolean, or it could be any, but it cannot be void, right? Void is not assignable to, or true is not assignable to type void, right? Okay, so up here, if we were to say not have anything, everything would be fine. But this specifically says, hey, you can't return. So if I have an empty return, it's fine. If I return a number, it's not fine, right? If I return true, it's not fine. If I return a string, it's not fine. So basically void just means you can't return. So we've got unusable, void is equal to undefined. Okay, if strict null checks is not given, right? So let's mess with that. So let unassignable of type void equal undefined. But if we have unassignable to type void be a string, now we have a problem, right? Type string is not assignable to type void. Okay. So null and undefined. In TypeScript, both undefined and null actually have their own types named undefined and null respectively. Much like void, they're not extremely useful on their own. Let undefined equal undefined, let null equal null. Not much else we can do with these. By default, null and undefined are subtypes of all other types. That means you can assign null and undefined to something like number. However, when you use strict null checks flag, null and undefined are only assignable to any and their respective types, which we're not going to do. I could see the value in it. We'll talk about that later. The one exception being that undefined is also assignable to void. This helps avoid many common errors. Yeah, I agree. In cases where you want to pass either a string or null or undefined, you can use the union type string null undefined. And union types are the way to handle this, rather than a string that's nullable. Union types are an advanced topic that we'll cover later in a future chapter. Also note, we encourage the use of strict null checks when possible, but for the purpose of this handbook, we'll assume it's turned off. Well, I'm going to turn that on. So a couple of ways you can do it. We're going to try to do it through the TSC. We're just going to pass it in right here, and it's strict null checks. Strict null checks. And that seems to have done the trick. And the way that we can find out, test strict null checks. We're going to let my null check of string equal undefined. Null. And then we run this, and we get an error. Type null is not assignable to type string. Now, if we were to drop the null check, it would compile just fine. right? So we know that strict null checks works, but we don't have our linter set up to handle that. So let's look at that. So we're going to do TypeScript Vim. And I think it's going to be this Sukuyomi. Gotta get better at saying that. Null. Maybe not. Do we have documentation? More details, please see doc. So this is longer, and we're gonna look for strict null. This doesn't seem to be in here. So we'll look at this guy. Doc. Ignore TypeScript, ignore TypeScript doc. We don't want that. What about null? We'll have to look it up a little later. For now, we can rely on the compile time check. All right, so the never type represents the type of values that never occur. For instance, never is the return type for a function expression or an arrow function expression that always throws an exception or one that never returns. Sounds like void. So we'll have to figure out the differentiation with that. Variables also acquire the type never when narrowed by any type guards that can never be true. Okay. The never type is a subtype of and assignable to every type. However, no type is a subtype or assignable to never, except never itself. Even any isn't assignable to never. All right, so let's see. So function returning never must have an unreachable endpoint. That's the key, right? In other words, there's an assumed return down at the bottom here. That cannot occur, basically. Infer return type is never. Inferred return type. Function returning never must have an unreachable endpoint. Got it. If there's any confusion on never, let me know in chat, but I'm going to move on for now. Okay, so object is a type that represents the non-primitive type. I.e. anything that's not a number, string, Boolean, symbol, null, or undefined. An object type, with object type, APIs like object create can be better represented. For example, we declare, and now we haven't talked about declare, what that does. Let's look into that real quick. But basically, I think it's like an abstract function. So let's go to TypeScript declare. Keyword. What does declare? Is declare JavaScript? Let's go to MDN. Doesn't look like it is. Declare. No. So, what do we need to declare in this statement? Declare versus var. Var creates a new variable. Declare is used to tell TypeScript that the variable has been created elsewhere. If you use declare, nothing is added to the JavaScript that is generated. It's simply a hint to the compiler. There you go. So we're saying, hey, TypeScript, it's okay. We're going to assume we have a function called create that takes argument O of type object or null, and it returns void. And then so we can say object, right, the curly braces, is okay, and null is okay. That's what this pipe means. It's an or. Object or null. 42 will be an error because 42 is not an object or null. string false undefined all error. Yeah, and then you can basically have a type, an object that inherits via the prototype another object, and that will work. So let's work with this. So we're gonna save and quit out of this, and we're gonna touch objects.ts. And in objects, we're going to declare declare, there we go, a function called create. It's going to have O, which is going to be an object, capital O, lowercase o, an object, or null, and it's going to return void. Okay, and that passes linting, and then we're going to call to this function. So we can just say create an object with a property that is 1, and that works. Now, if we create with 1, that should not work, and it in fact does not. Type 1 is not assignable to type of object. So what we're going to do is we're going to pull out this object, and we're going to say parent object is going to be equal to that object. And to make it clear that this is an object, we'll just fix the syntax a little bit, and then we'll pass in parent object in here. What are we getting wrong here? Let. Okay, so we've got that defined. Now we want a child object, and it's going to have its own property, right? And we're just going to call it property 2 is 2. And back into this one, we'll call it property 1. Now, that child, right now, it's just a subtype of object. What we want it to be is a subtype of the parent object. So, child object, I misspelled that. Child object. Okay, so child object dot. So this is pseudo classical instantiation, and I'm trying to remember the syntax for it off the top of my head. I know we're gonna need. All right, let's look it up. JavaScript pseudo classical instantiation, something like that. So this is an instantiation pattern, and I'm just looking for a little bit of code here. Where is .call? So animal object create object methods. Maybe I'm getting this all mixed up in my head. JavaScript call example. So we've got function product, food, the product.call. Yeah, this is what I'm looking for. All right, so child object here we go. Dot, or no, it's got to be the parent here. So this would be parent object, parent object dot call with this. See why it's angry. Expected, comma, is, oh, because it's a function. Oh, right. Okay, so that's what I'm missing. So we have a parent object that is a function, and it is property 1 is 1. And then we need to specify nothing. And then we have a child object that is a function who's got a call to maybe this. And we could probably have this in here. And we need some lets on these. So child object is equal to function. What's it angry about? Property create does not exist. Property create. Did we call create? Ah. Okay, so does not exist on type property number. Okay. Not sure what that has to do with anything. So we're going to remove this for the moment. Just save this, see what we get. So cannot redeclare block scope variable child object. Oh. And then not assignable type property to number is not assignable to void. I'm not sure what that means. We'll just do this for now. Okay, so we're going to console log child object and see where that gets us. So TSC, and instead of types.js, we're dealing with objects. So we get our child object. I want to, in TypeScript, print entire object. And it looks like I guess it would be in Node. We could JSON parse it. JSON stringify it. Let's do that. JSON.stringify that. Undefined. Oh, we need to have a new instance of child object. Right, so new child object. There we go. Looks empty at the moment. We can see we would expect, so this passes in, sets some internal, we don't have this set. This dot and this dot. This dot. So what's it angry about? Available, QF available, is equal to, right? Because we're inside of a function. Okay. So this call cannot read property call of undefined. Oh, it's not this dot parent object, right? Parent object exists outside the scope. We are passing, when we do call, we're passing this scope, which is the child object scope, into the parent, which means property gets passed in. And now we can see property 1, property 2, right? So now if we were to just do new parent object, we would see property 1 and then property 1, 2 for the child. Even though we never declared property 1 on this child, it's inherited from the parent. So back to the documentation, now that I've struggled through that. We've got this create function. What stimulated that entire thing? Okay, object, right? So for create any object. So parent object extends object, and then child object extends parent object. So I should be able to console.log create a new child object. And that should technically work, right? And if we run it, we see that everything is not fine. Oh, create is not actually defined. Like we said, this declare here is just pretending like the function would be defined. So I'm going to define it. I'm going to call it function create. I'm going to let hoisting happen. In fact, you know what? I'm not, because I don't like hoisting. So I'm going to call create as a function. It'll return void. It'll take an object, and we'll just console.log the object itself. JSON.stringify O. Like so. And it doesn't return anything by definition here. So now, if we run this, we see that it does in fact work, but we are seeing undefined come in here. And that seems, let's see. That shouldn't be the case. We create a new child object. We pass it into create. That gets assigned to O, and we JSON stringify O. And so we would expect, let's test this out. So obj is going to be, and we gotta do let here, right? Let obj equal to new child object. And then we'll just pass in obj and run that. And we're still seeing undefined. Create function. Double quotes. Oh, so create function is there. So, oh, that's my mistake. So because create is void, of course, undefined is going to come back from that. So now we can see that this is working. So create function is getting in the object that's a child and printing it successfully. Now at runtime, you can modify this object. So O dot, let's say property 3 is equal to 3. Oh, but because it's TypeScript, it's going to prevent us from doing that. Yeah. So let's look real quick at objects.js. So this, and notice the difference here on line 1 through 3. They're fundamentally the same except types are being removed, right? So I'm just going to modify the JS to prove something out. So o.property3 is equal to 3. And then if I just node objects.js, we can see property 3 here. You can get away with this in JavaScript. You cannot get away with the same thing, o.property3 is equal to 3. That seems not to work. Could we do like a let? And then it's going to say, hey, duplicate identifier. It's already declared, and var won't help you either. Maybe down here, if I declared it with var, and then I could potentially do that. Nope, it just will not let you do it, right? Which is great. I'm all for that. Anybody in chat, let me know if there's another way to dynamically declare properties on an instance of an object in TypeScript, but I don't believe there is. All right, so that's objects in a nutshell. At the same time, we can still pass in, null, and then we'll say if O is null, then we just want to return. Now notice we're not returning a type, so the transpiler should be happy. Sorry, this is still JavaScript syntax for the ifs. And now if we run this, we'll transpile and run it. We can see that everything works. We could also console log null found. And then at the end here, since we're passing a null, we should get null found, which we do. Okay, so that's objects, and that's also, what's that called? Union types, right? So the union type is either object or null, and this makes it a union type. All right. Type assertions. Sometimes you'll end up in a situation where you'll know more about a value than TypeScript does. Usually this will happen when you know the type of some entity could be more specific than its current value. Type assertions are a way to tell the compiler, trust me, I know what I'm doing. Type assertion is like a typecast in other languages, but performs no special checking or restructuring of data. It has no runtime impact, and it is used purely by the compiler or transpiler. TypeScript assumes that you, the programmer, have performed any special checks that you need. Okay, so this is basically just a way to silence just a moment. Make sure I'm still streaming. Yeah, so it's just a way to silence the compiler. All right. Let's move on. So type assertions have two forms, one that is angle bracket syntax and the other as syntax. So we let some value of any say this is a string, and then the string length is a number, and we're going to say, hey, some value is definitely a string. Even though it could be any, it's going to be a string because string has a length. And then we could also say, instead of doing this generic syntax, we're going to use the as syntax. Some value as a string, which then tells the compiler, hey, we've got length here. We know we have length here. Trust me on this one. All right. Two samples are equivalent. Using one over the other is mostly a choice of preference. However, when using TypeScript with JSX, only as style assertions are allowed. So I think this would mean that if you're programming React, you are going to be stuck with the as style syntax. As much as I like generics, I feel like this reads better. So I would probably prefer the as syntax myself. A note about let. You may have noticed so far that we've been using let keyword instead of JavaScript's var keyword, which you might be more familiar with. The let keyword is actually a newer JavaScript construct that TypeScript makes available. We'll discuss details later, but many common problems in JavaScript are alleviated by using let. So you should use it instead of var whenever possible. Well, unless the compiler is more intelligent than I'm giving it credit for, the problem is we're seeing let not be used at all in transpilation. So I'm going to Google that real quick. TypeScript compiled code uses var instead of let. Let and var are the same in TypeScript. Let's look it up. But it isn't. The compiler ignores the let command and turns it into a var command. Why does this happen? Does TypeScript only work properly with classes? The compiler by default transpiles to ES3. The let keyword doesn't exist in ES3, and so the emitter must emit code in the syntax available in ES3. In this case, the best replacement for let keyword is a var keyword. If you want to emit with the let keyword, then you must target ES6. Target ES6 in tsconfig.json. Let's look. Do we even have tsconfig.json? We do not. So we're gonna wait on this one, even though the correct thing to do is to target ES6, because all modern browsers are ES6 compatible for the most part, if not entirely. So we're going to go ahead and leave it targeting ES6 for now. Let it be the vars that it is displaying for now in the JavaScript. And then when the handbook teaches us about tsconfig JSON, that's where we'll declare our target towards ES6. And that's also where we'll declare strict null checks. So for now, we're just going to leave it. All right. So thus concludes our chapter on the basic types. And then let's zoom all the way back out so we can see our handbook on the left here. Next, we're going to go through variable declarations. And I think I'm just going to keep trucking on through here. We've still got a couple hours of stream time left. So any questions on that section, feel free to ask. Otherwise, variable declarations are coming right up. I'm going to take a very short break, and I will be back soon. And we're back. So let's go ahead and dig into variable declarations. All right, so let and const are two relatively new types of variable declarations in JavaScript. Relatively. As we mentioned earlier, let is similar to var in some respects, but allows users to avoid some of the common gotchas. Const is an augmentation of let that prevents reassignment to a variable. So let prevents reassignment of a variable, const prevents reassignment to a variable. All right, so with TypeScript being a superset of JavaScript, the language naturally supports let and const. So declaring a variable in JavaScript has always traditionally been done with var. As you may have figured out, we declared a variable a with value 10. We can also declare a variable inside of a function. We can also access those same variables within other functions. In the above example, G captured the variable a declared in f. That's not confusing. G captured a that was declared in f, right? So inside of here, we've got a function and a function. A gets set to 2. B calls G. So B becomes 2. A is set to 3, and then we return B, which was 2. Okay, so it's copy, not reference. Right. var declarations have some odd scoping rules for those used to other languages. Take the following example. We've got a function called f, should initialize as a Boolean. If it should initialize, var x is equal to 10, and we return x. So if f true, we return 10. Otherwise, we return undefined, which makes sense. Some readers might do a double take at this example. The x variable was declared within the ifs block, and yet we're able to access it from outside that block. And that's the thing. var is not block being these curly braces. It's not block scoped. Let is. The scoping rules can cause several types of mistakes. One problem they exasperate is the fact that it is not an error to declare the same variable multiple times, right? So you've got I declared here and I redeclared here, and that just messes with this whole counter. Maybe it was easy to spot out for some, but the inner for loop will accidentally overwrite the variable I because I refers to the same function scoped variable. Variable capturing quirks. Take a quick second to guess what the output of the following snippet is. All right, so I is 0, I is less than 10, I increases. Then we have a set timeout function console log I. So times 100 times I. Right, so that's going to be 10 at the time of the timeout into the function. Yeah. Many JavaScript developers are intimately familiar with this behavior, but if you're surprised, you certainly are not alone. Most people expect an incrementing count. But set timeout messes up a lot of things. Remember we mentioned earlier about variable capturing. Every function expression we pass into set timeout actually refers to the same I from the same scope. Right, so it's like a reference. Let's take a minute to consider what that means. Set timeout will run a function after some number of milliseconds, but only after the for loop has stopped executing. By the time the for loop has stopped, I is 10. A common workaround is to use an immediately invoked function expression to capture I at each iteration, right? So this is the iffy here, right? And then here. and then we pass in I, that as it is in that moment, into this scope. Pretty messy. Odd looking pattern is actually pretty common. The I parameter list is actually shadows the I declared in the for loop, but since we named them the same, we don't have to modify the loop of the body too much. Okay, I would rather see everyone using let. So we've got let hello, it's block scoped, so B plus A, well A is okay to reference because it's external parent of the block, so you can do that. But B here does not exist, right? Yeah, B does not exist here because we returned early in the if statement. Variables declared in the catch clause have similar scoping rules. So console log oh well, throw oh no. We get E. Another property of block scope variables is like they can't be read or written to before they're actually declared. Right. A++ is illegal because let A is declared after A++. Foo returns A. Illegal call foo before A is declared, because A is after foo. For more information on temporal dead zones, see relevant content on MDN. Yep. With var declarations, we mentioned that it didn't matter how many times you declared variables, but with let, you can't redeclare within the same scope. All right. So this errors interferes with parameter declaration here. This errors because it interferes with variable declaration. Okay. So this is that's not to say block scope variable can never be redeclared within a function scoped variable. The block scope variable just needs to be redeclared within this distinctly different block. So X comes in, we open up a block for the if condition with this curly brace, and we can redeclare X. Now, this is going to return 100, but when we get down here, we're going to return whatever X was when it was passed in. So false returns 0. True returns 100. And if you didn't return here and you let X equal 100, this would still be 0. Once it left this scope, this would basically no longer be the value of X. Think of them as two totally different variables. The act of introducing a new name is in a more nested scope is called shadowing, right? So this is the shadow right here. It's a bit of a double-edged sword in that it can introduce certain bugs on its own in the event of accidental shadowing, while also preventing certain bugs. For instance, imagine if we'd written a similar sum matrix function using let. So we had sum, let I. So this I for the current row is accurate to the I in this scope, and the I in matrix is accurate to the I in this scope. Now, if this was called O, then this I would refer to this I. But since it's called I here, with a let declaration, we know it's shadowing. This version of the loop will actually perform the summation correctly because the inner loop's I shadows I from the outer loop. Shadow should usually be avoided in the interest of writing clearer code. I tend to agree. Yeah, I would definitely tend to agree. While there are some scenarios where it may be fitting to take advantage of it, you should use your best judgment. Let get city if true. Let city equals Seattle, getCity becomes a function that returns city, and then we return getCity. That will work. Yeah, okay, I think that will work. Because we've captured city from within its environment, we're still able to process or access it despite the fact that the if block has finished executing, right? So we basically sort of injected it into this function. Recall that with our earlier set timeout example, we ended up needing to use an iffy, immediately invocable function expression to capture the state of a variable for every iteration of a for loop. In effect, what we were doing was creating a new variable environment for our captured variables. It's a bit of a pain, but luckily you'll never have to do that again in TypeScript. Good. Let declarations have drastically different behavior when declared as part of a loop. Rather than just introducing a new environment to the loop itself, these declarations sort of create a new scope per iteration. So you can do lets within. Since this is what we were doing anyway with our immediately invoking function expression, we can change our old set timeout example to just use a let declaration. So for let I, then we had our set timeout, but because we're using let, it's creating the environment, and we can just use our set timeout, and it'll count as expected. Okay, so for const declarations. Const declarations are another way of declaring variables. Okay, so you just can't change. So let's talk about consts real quick. So I'm gonna get out of here, and we're gonna cd up a directory. First off, let's go ahead and add basic types, and we'll make a commit saying covering basic types, and we'll just we'll keep that as a commit, kind of our initial commit. And then we're going to make a directory for where we're at now, which is variable declarations. So make a directory for variable declarations. And then I really want to talk about consts in TypeScript and JavaScript. So for consts, let's go ahead and let const my constant is equal to a, and then we'll do my constant 2 is equal to an object, and that object has property 1, which is a, and property 2, which is b. And then we're just going to console log my constants. Okay. And then inside of our variable declarations, we're going to do our TypeScript voodoo magic here. So basically the compilation, we're going to call it consts.js from consts.ts with strict null checks, and we can see that we get so for the first one, let's separate these for clarity. Okay, so we've got my constant 1 and my constant 2. And we'll see a, and then property 1, a, property 2, b. If we were to try to say here, my constant 1 is equal to b, we're going to get a linting error. And it's going to say my constant 1 cannot be assigned to because it is a constant. Right? Great. Makes sense. Now, how about my constant 2? So my constant 2, and we're going to say, dot property 1 is equal to C. And unless TypeScript catches it, this should work, which it does, right? So now we run it and we see CB. And so right here we've got A, B. Then on line 9, we change my constant to property 1 to C. And then we see CB. So don't let yourself be fooled. Constants, like basically I couldn't say my constant 2 dot or is equal to A, right? That won't work because I'm trying to change constant 2. Now, if I tried to change the object that constant 2 contains, I'm totally allowed to do that. I might be able to specify const. Nope. Yeah, it's not doable. At least this is probably where structs are going to come in here in TypeScript. But this is the behavior of JavaScript right here. You can totally mutate the object that the constant is holding without violating the constant itself. Just the way JavaScript works. Okay. So that basically summarizes everything I was talking about. See, all these are okay. We can't redeclare kitty as a totally different object, but we can mutate the object all we want. Let versus const. Like I said, the only difference, well, let's read through this. So given that we have two types of declarations with similar scoping semantics, it's natural to find ourselves asking which one to use. Applying the principles of least privilege, which we should read into, all declarations other than those you plan to modify should use const. I agree, right? It's the default that you should start with unless you're thinking about changing it. Use your best judgment, and if applicable, consult the matter with the rest of your team. The majority of this handbook uses let. It's like violates its own rule. That's fine. The way I think about it is const is a variable that cannot be changed, and let is a variable that cannot be redeclared. And use that when it makes sense. It's simple to change a const to a let, so just use const and get ready to change it. So destructuring, right? Destructuring basically lets you take an array and put it into multiple variables. So this is as simple as it gets, right? So 1, 2 is input. If we want to destructure it, we say let, and then we create this bracket syntax. This is not an array. This is a grouping of variables. The first variable's name is first, the second is second. And then we can just console log first and second, and it's destructured from here. Right. Destructuring also is useful in functions that we'll get to. This creates two variables, the equivalent of using indexing, but is much more convenient, especially when you're working with very large arrays or something. And then I like this one, swapping. So you just want second to become first and first to become second. Now this is interesting because it's like, you would think if second becomes first, well then first would be second, but it's not, right? So this magic works. And with parameters to a function, right? So first takes first and second, destructured from, and those both have to be number types. And then we just pass in the array 1, 2, and we get first, second that we can reference in here. Now, creating a variable from the remaining items in a list using the triple dot syntax. So, first rest is 1, then 2, 3, 4 becomes an array, 2, 3, 4. right? So this is like almost like a unshift, and then you have the remainder. Or of course, since this is JavaScript, you can just ignore the trailing elements you don't care about. Yeah, right. So first becomes this, and the rest just gets discarded. Other elements, let, so second, fourth, that's pretty dirty. Sure you can. I can't think of when I actually would. So tuple destructuring. Tuples may be destructured like arrays. Destructuring variables gets the types of the corresponding tuple elements. So this would be a number, a string, and a Boolean. And then it's an error to destructure a tuple beyond the range of its elements. This would end up being a linter error. So you wouldn't be able to compile this, and your editor would also alert you of this instance. That's a nice thing about type safety. As with arrays, you can destructure the rest of the tuple with the ... and you can also ignore part of the tuple. Ignore the trailing elements or other elements. So tuples and arrays, remember they're fundamentally the same when they transpile. They're just arrays. The only thing tuples give us is type safety in TypeScript. All right, so destructuring an object happens within the curly braces. So property A and property B would get these two properties out of O. This creates new variables A and B from OA and OB. Notice that you can skip C. Like array destructuring, you can have assignments without declaration. So, and by without declaration, they mean like without the let variable or keyword and the O variable. In other words, you just have this object and you directly destructure out of it into A and B. Now, let's look at this because this is going to be kind of important. So we're going to touch destructure objects .typescript, and we'll vim that. So if we have, let's say, let object, type object equal an object, and it's got A, which is 1, and B, which is 2, and C, which is 3. And then we have a function, we'll call it destructure. It's going to be a function, and we're going to use arrow function syntax. We're going to write a function, then we'll convert it to arrow function. So function becomes a destructuring that has A and B, right? And we're just going to return, we're going to console log A and B. And that's all we have to do. And then we just, cannot find name destructure, let. Okay, and then we have to have these inside of this syntax. No. Function AB. Does it have to be from? Of type? OBJ? I'm not sure how to do this in TypeScript yet. Let's do this with just a regular function for now. So, that's the problem. I said I was going to write a function, and then I proceeded to write an arrow function. Whoops. So we're going to just do an arrow function, I guess. Okay. So let's write this in 2 ways. So we'll just do destructure 1 and 2. Now I'll convert this to a function that takes A and B, okay. This is the two ways you can write this, right? You can see I open up the brackets here. Do I even need to do that? Yes. So this is to say, hey, what am I destructuring? Or what am I pulling out of the input? And it's going to be A and B from destructured from an object. And I'm not sure if I can specify that object to be obj. Obj refers to a value, but is being used as a type here. I guess it would be type object. Okay. We're just going to leave it like this. I think I could do any, and that would be fine. In order for object to be an object, I would have to create it as a function. We're not going to do that right now. So let's go ahead and do this. So we're going to move to the end here, and we're going to call this destructure objects.js. And we'll call this destructure objects.ts. We run it, and we are getting a module. Cannot find module. Variable declarations. Destructure object.js. Objects. There we go. Okay. And now we need to call these, right? So this would be destructure 1. Just call it. And then expected 1 argument, we're going to pass an obj. Type object is not assign. Let's see. Operates from type A. What is it saying? Argument type of type object is not assignable to parameter type AB. Type object is missing from type AB. Okay, I think this is some TypeScript stuff. So what I'm going to do is I'm going to make object, let object equal a function. And this will be this dot A, this dot B, this dot C. And this is going to have to be equals. Equals. And then I think at that point I can say as obj. Refers to a value. I'm not sure how to do this. Yeah, we're probably going to get into this a little later. Let's see, what is it recommending? I let A and B equal O. So let's just do that. Let's not worry about these arrow functions and functions. And just let A and B equal to object. It's still upset. Oh, because this needs to be here. These need to go back. This needs to become colon. Get rid of this. And these need to become commas. Commas? A, B, C, let equal to an object. Okay, so now this is legit. So if we console log A and B, and we run this, we will see 1 and 2. Now, if we switch this to C and rename this C, we get 1 and 3, right? And if we tried to do D, we'd immediately get an error saying, hey, D is not declared. But what if we wanted A to be named something else? That I'm not sure about, right? So let's see what they've got in store for us. Notice that we had to surround this statement with parentheses here, this whole thing. JavaScript normally parses a curly brace as the start of a block. So we want to tell it that it's not a start of a block. You can create a variable for the remaining items in an object using the triple dot syntax. A ... pass through. So total would be pass through.b, pass through.c. Right. Pass through becoming the object remaining. Okay, so here it is. Here's how you name it. So instead of this being a type, it's going to be another variable name. So new var 1, new var 2, and then we can say new var 1, new var 2. And now we'll have 1, 3, and we can just say change this to B. We don't have to refactor new var 2, and we get 1, 2. Okay. Here's the syntax. Starts to get confusing, so you can read a new name 1 as a as new name 1. The direction is left to right as if you hadn't written it. Let new name 1 equals o.a. Right? Confusingly, the colon here does not indicate the type, as I specified. The type, if you specify it, still needs to be written after the entire destructuring. So basically what that would look like would be, it gets kind of weird. Ready? It's going to be destructure colon object, and then it's going to be number. Like, oh, sorry. A number, B number. And then if we were to change this to C, we would get an error. C does not exist on type A number, B number, because it's like a definition of this. So, and I don't think I can delete to here and say obj, right? Because obj is a value, not a type. Okay. Default values let you specify a default value in case the property is undefined. So that's this question mark here. And if this question mark is supplied, then it's going to equal 1001 if whole object does not contain B. So let's do that, right? We want D as new var 3, and it's going to immediately complain that we don't have it over here. So we're going to say, hey, D needs to be a number, and then that should complain because D is missing, right? D is missing from A, B, C, basically from object. But if we say it's optional, then everything's fine. But new var 3 will then be undefined, I believe. Right, 1, 2, undefined. So when we're doing that, we need to say, hey, new var 3 or 4. And now we have 4. Let's change that to 5 real quick for the sake of example. And we'll replace this here and we'll make it 4. So now we've got 4 in our object. We'll see 1, 2, 4. But if we didn't have it and we had it declared as optional here, right here, then it would go to this value by default. Okay. Function declarations. Destructuring also works in function declarations. For simple cases, this is straightforward. So type C. Here is the type. So that's what it is. So type, capital T? No. Let's just type. Type object. So now we're going to make the type capital and the declaration not. So now we want to say that instead of this nonsense, the type can be D optional number, number, and then we can maybe just say obj. There you go. And that compiles. And if we just include D, we can have 4 here. And that's how you get custom types, right? Okay. Take just a minute here, drink a little water. All right, and we continue. So we've got our type here declared, which they just kind of threw that in, I think. There was no mention of types before. Whatever. It's easy enough to understand. It's an object, but instead of values, you give it a colon and a type, and then you can also specify optional. You can't specify default. It's more of an interface in that sense. By specifying defaults, but specifying defaults is more common for parameters, and getting defaults right with destructuring can get tricky. First of all, you need to remember to put that pattern in, to put the pattern before the default value. Okay. The snippet above is an example of a type inference explained later in the handbook. So it's going to be inferring that this is a C type, I suppose. Then you need to remember to give the default for optional properties on the destructured property instead of the main initializer. Remember that C was defined with B optional. So, function taking in A yes is going to have B 0. Function of nothing passed in, it's going to default A to blank. Oh, because we can specify the default up here as well. Oh no, it's not specifying the default. It's creating the object here. Default A, which, okay. Okay, so this is defaulted to this if something is not passed in. That's what that means. This will error because A is required, and because we passed in an object, this default no longer works. Use destructuring with care. As the previous example demonstrates, anything but the simplest destructuring expression is confusing. Agreed. This is especially true with deeply nested destructuring, which gets you really hard to understand, even without piling on and renaming default values and type annotations. Try to keep destructuring expressions small and simple. You can always write these assignments that destructuring would generate yourself. Right. Okay, so now we'll talk about the spread operator. Spread operator is the opposite of destructuring. It allows you to spread an array into another array or an object into another object. So first, 1 and 2, second, 3 and 4, both plus 0, plus first, plus second, plus 5 would be 0, 1, 2, 3, 4, 5. And that's in the spread. You can also spread objects. So you've got defaults and search. So search would become an object. Food, spicy, price, ambiance, food, rich. So we would see rich, price, and ambiance. So this is like a combination, not a nesting. And spread offers that by default. Object spreading is more complex than array spreading. Like array spreading, it proceeds from left to right, but the result is still an object, not nested. This means the properties that come later in the spread object overwrite properties that come earlier. So if we modify the previous example to spread at the end, rich becomes spicy, right? Food property and defaults overrides food rich, which is not what we want in this case. Object spread also has a couple of other surprising limits. First, it only includes an object's own enumerable properties. Basically, that means you lose methods when you spread instances of an object. So if you've got an actual class with P12 and a method, you're going to create a new instance of it and then clone. You're going to see, hey, you got your property, but you lost all your methods in the process. It's an object spread, and it just loses some of that information along the way. Second, the TypeScript compiler doesn't allow spread of type parameters from generic functions. That feature is expected in future releases of the language. I'll take you at your word. Okay, so that makes sense for variable declarations. Let's go back to zoom out here so we can see the menu on the left. We're going to go through interfaces next, classes, functions, generics, enums. There's just a whole lot that we still have to touch on. So we're going to take a quick break, maybe 5 minutes, stretch, get some water, take in everything we've talked about, and let me know in chat if there's anything wrong with the stream, if it's choppy, if it's buffering and pausing a lot. Helps me a ton. So I'll see you shortly. Okay, we are back. So we're going to be looking into interfaces. First, before we dive into that, I want to just clean up the tabs that I opened from the last section. Although there's a couple of those that we meant to look into, and I think it's the enumerability and ownership of properties, and then the principle of least privilege. So this is a principle in computer science and other fields known as the principle of minimal privilege, or the principle of least authority. Requires that a particular abstraction layer of a computing environment every module, such as a process, user, or program, depending on the subject, must be able to access only the information and resources that are necessary for legitimate purposes. So it's better to restrict than to leave open. And it's better to, in terms of variables, leave it as constant and then move to let and var or enums, etc. as needed. So that's that. And then we're going to leave this one for later. So let's dig into interfaces. So first thing we need to do is close out this code that we have. We'll go up a directory in both locations, and then let's see, git add variable declarations, and we're just going to say worked on variable declarations. And then that created destructuring objects.js and ts for both of those. We could probably exclude the JS, but we're going to leave it for now. So now we're going to make a directory called interfaces and go ahead and cd into there. In both cases, and we're good to jump in. This will probably be the last section I do for the night, and then we're just going to continue working through TypeScript. Also on here we're doing Rust. We do Go code challenges. We're probably going to do some TypeScript code challenges in the future, and I'm also going to pick up Nim as a programming language probably after I'm done with Rust and or TypeScript, whichever comes first. So that being said, let's dig into interfaces. So one of TypeScript's core principles is that type checking focuses on the shape that the values have. This is sometimes called duck typing or structural subtyping. There's that, like, I don't know, nomenclature or terminology that if it walks like a duck and it quacks like a duck, then it's a duck, and that's the idea with duck typing. And interfaces will express that. So in TypeScript, interfaces fill the role of naming these types and are a powerful way of defining contracts within your code as well as contracts with code outside of your project. So our first interface will be the easiest way to see how interfaces work, and it's going to be this example. So we're going to go ahead and do this. So we're going to have a function called print label. It's going to have a labeled object of a type of labeled string, label property with a string type, and then we'll create an interface for this. So we'll touch a non-interface.ts. So I like to do function expressions rather than this function declaration that can be hoisted. So I'm going to call my function print label. Print label is equal to a function, and it takes in a labeled lady labeled. Okay. And that's going to be an object with label property set to string. we have to, of course, call it as a let, and we'll go with that principal, right? The principal that was least privilege. So we make it a const. And I'm going to just take it upon myself to do consts wherever possible, unless I need a let, even though the documentation is not doing that. Okay, so now we just console log labeled object label. Console log labeled dot label. Okay. And then we have an object that will just requires a label as a string. So const, we'll just call it obj. Oh, fun. We get our first band. That's cool. Let's go ahead and go to Nightbot TV. And you can watch me ban you if I can figure out how to do it. Actually, I think I might just be able to do it through here. What's the name? 156. 156. I don't see it. Spam protection. We'll just block words. I just really want to blacklist you, so let's Google it. Twitch. Ban user. Ban a user. Look, you're teaching me all sorts of new things. Oh, so I can just type into chat. Can we do it kick for time? Kick? And we'll just ban. Tell you what, I'll leave you not banned for the moment, and if you prove that you need banning, I will do this little line here. And that'll be nice and fun for me. Alright. So, and I'm just gonna go ahead and get that off my screen. Thanks for that. I don't see his name in the chat, that's the thing. He's just not popping up in here. Like, I could click on you and I could do all sorts of things. Timeout user, that's probably what I would do to him, but he's figured out a way around that. Maybe I'll just refresh this. Yeah, he's just not in there. That's fine. I doubt he'll do it again. All right, so, yeah, where were we? We were creating an object equal to object, and we just want size of 10, could be anything, and then label size 10 object, size 10 object, and that's it. That's our object, and we pass that into print label obj, and that console log. So we want to TypeScript and this is going to be called non-interfaces. Non-interfaces TS, compiles it into JS, and we see size 10 object, right? This does not use interfaces. So let's go ahead and figure out how to use interfaces. So we can specify an interface keyword, give the interface a name, describe the shape that the object should be. In other words, it should have label and a string, and then we can just reference that interface here. So this is different than type, right? And this is the duck typing. We can just make any object that adheres to this interface. And when we pass it in, if the object looks like a labeled value, then it is. And this is like type inference, basically. Okay, so let's go ahead and work on that. So we're going to create one called touch interface.ts, and then we'll just open up interface.ts. We'll create an interface called a labeled value, and it's just going to have a label type string. That's all it needs. And then we're going to have we're just going to go ahead and vertically split my non-interface on the right here so I can reference it. I opened up the wrong one. I opened up the JS. So I'm actually going to open up the non-interface TS over there. And then for the non-interface JS, I'm just going to delete that buffer. And then vertically split non-interface.ts. Okay. Okay, so now we're going to have our const for print label. It's going to be the function. We're going to pass in labeled, and it's going to be the labeled value. Let's go ahead and shrink this. You know what? I changed my mind here. This was a bad split decision. So we're going to quit out of that split and just split below for non-interface TS. There we go. All right, so now we have our type for labeled value for our function. Instead of having this whole section here be an object, we just have the interface here. And this interface references this interface on line 1, right? And that's going to open up, and we're just going to console. Basically, we're going to take this line and repeat it, and then we can take these two lines and repeat them, and then we can quit out of that split. So now if we type check, and instead of using non-interfaces, we just use interfaces, we can see the same result, right? Size 10 object with that interface. Just to prove that this is working, if we change this to number, we're immediately going to get linting errors. An argument basically says, hey, string is not a number. You know, you're going to have to change that. Or what we could do is we could say we want size to be a number, and that would work. And then because we've done that, we can reference size here because size is part of the labeled value. If we didn't have size here, we would also get a linting error, right? And this is the power of TypeScript. One of the many examples of it is we're being very strict where we want to be about what we want to have the compiler and the linter catch. And the goal here is to reduce bugs, right? Because in JavaScript, it's the Wild West. You can almost do whatever you want. All right. So interfaces can also have optional properties specified with question mark. You can also do union types. So like a number or null could be here, and then we could have two objects. We could have object 1 and object 2. And so say that size by default is null. Object 1 gets passed in successfully. And object 2 gets passed in successfully, right? If we didn't have this union type here on line 2, we would get I guess, why would it allow that? Let's find out if it allows that. Oh, I have strict null checks on, right? It allows it because I didn't have strict null checks. Another way we could think about this is, let's have this be a string, right? And now we're going to get the error, right? And it's going to say, hey, argument string is not a number. But if we allowed a union type of string, well, then it would be fine. And it compiles fine, and it console logs fine. Null is not assignable. Sorry, I didn't save the TypeScript file. So now we run it, and we can see that that works as expected. And if we want even more clarity, we'll just get rid of the label and show the size, because that's what we're working with. And we can see 10 and string. And that's strictly due to our interface allowing a union type of number or string. And then if we get rid of that, it freaks out because this is not a number. So we can make it 1, and then it's happy. So that's union types inside of interfaces. How's the buffering in chat? Is everything looking good? Let me know. Also curious about the delay on the stream. So null is allowed by default. Okay, so yeah, if you don't have this flag here in TSC, so let's make this bigger. So clear this out up here at the very top. This -- strict null check. If that isn't there, the nulls are allowed, but it is recommended by both the handbook and myself that you use strict null checks, because you don't want nullable types in general, because then you've got this situation where you have to do something like this. So let's take this off for a second. Right, and this will compile, and then we'll change this to null, and we'll run it, and we get null here. 15 seconds delay, that's not too bad. I can work on getting that more real time. I'll do that in the future. Okay, so we've got this as null now, right? So what does that mean? What can't you do with null? So let's say console log labeled.size +1, and we run that, right? So we get sorry, let's get rid of that. We'll just console log that. So we get 11 and 1. So a lot of this is going to be handled by JavaScript's type coercion. It's basically going to say, hey, yeah, we can do things with null, no problem. But basically there could be a scenario where you say if labeled.size is equal to null, then console log you're in trouble possibly if you don't check this. And then otherwise we'll print the labeled size. So then we compile, and then we see that you're in trouble possibly if you don't check this. And that's the thing. So if we then pass with strict null checks and we try to run this, the compiler is just going to say, hey, null is not assignable to type number. And that's just the way it is. So that's probably the way I would handle it, personally. I can't think of a contrived sort of example to demonstrate this, but they exist. I just am drawing a blank, probably because it's like 11:40. Let's Google it. Like, why should you use strict null types in TypeScript, right? Do's and don'ts. Null versus undefined, strict null check, deep dive. All right. Non-null assertion operations. No. There's not a lot of reasons there. Strict null checking. The second reason, when a consumer uses the strict null checking feature of TypeScript, because unspecified parameters appear as undefined in JavaScript. Right, so let's do that. So instead of this, we'll say undefined. Can we do like console.log labeled size +1 with undefined? That's going to fail because we've got strict type checking. Yeah, so TypeScript doesn't use type coercion. JavaScript does, and we'll show you what that looks like here in just a second. There we go. Boom. I tried to add 1 to undefined, and I get not a number. And not a number is a type in JavaScript, right? And that's annoying. That's just annoying behavior. I don't want that kind of behavior, so I use strict type checking. Now, to answer your question, if we list out here our directories, we see that we've got 4 files. Ignore the swap file. In fact, we'll just lsla. 4 files. Interface.ts, which is TypeScript, and interface.js. TypeScript is nothing more than a developer convenience and a compile time check convenience. What it compiles to or transpiles to is JavaScript. So if we open up interfaces.js, we can see that this is ES3, not ES6, but ES3 compatible JavaScript that will run in like Internet Explorer 10 or whatever. And so the coercion is happening for you automatically, right? So right here, when I try to do label.size, which is undefined for object 2, it's going to be undefined +1. Well, if we were in the browser and we brought up a console and we said undefined +1, you get nan, right? So fundamentally, we're still just running JavaScript, and that's what Node.js does. Node.js doesn't know anything about TypeScript, which is why when I, am I in the right one? Yeah. When I run this command, what we're doing is 2 separate things here. We're doing TSC, which is the TypeScript compiler. We're taking interfaces TS, and what that's doing is it's running compile time checks, making sure everything's good to go, and then it's converting TypeScript into JavaScript. And then we got this and, which will wait for that compilation to complete, and then we say node, which is going to be Node.js, and then we pass it the JS file specifically that's created. If we tried to do node interfaces.ts, we're going to get an error. And it's going to say, hey, unexpected identifier here. And it doesn't even know how to handle interface, let alone the name of the interface. Node just isn't meant for TypeScript, right? So they're 2 separate technologies working in concert with each other for a better development experience. And this is where things like Webpack and Babel come in, is to sort of manage all of this tool chain that you use to develop. But really, when it comes down to it, you're just sending a JavaScript file across the network connection to the browser. And that's what the clients are ending up running, is that JS file. Hopefully that was descriptive. Okay, so optional parameters. Don't write several overloads that... Am I in the right place? I think I missed something. Oh, I'm way in the do's and don'ts. I need to get back on track. Okay, optional properties. Better. So not all properties of an interface may be required. Some exist under certain conditions or may not be there at all. These optional properties are popular when creating patterns like option bags. when you pass an object to a function that only has a couple of properties filled in. So we've got an interface for a square config. It's got an optional color that's going to be a string and an optional width that'll be a number. Totally ignoring it. Don't worry. Function create square will take a config argument of type of interface square config, and it's going to return. This should be a type. I would make this a type. But basically it returns an object of color, string, area, number. So we create a new scoped variable called new square. It's going to be white and area 100. If config has color, we're going to override the color using the config's color. If the config is width, then the area is going to be width times width. And then we're going to return the new square, or width squared, basically. And then let square create square color black. So we know we're going to get black of an area of 100, right? Interfaces with optional properties are written similar to other interfaces, with each optional property denoted by a question mark. The advantage of optional properties is that you can describe these possibly available properties while still also preventing the use of properties that are not part of the interface. For example, had we mistyped the name of color in property create square, we would get a message letting us know. It would say error property color does not exist on square config. Cool. Read-only properties. Some properties should only be modifiable when an object is first created. You can specify this by putting read-only before the name of the property. Now, Indian read-only, right? So read-only, was this in CSS? I think read-only is a TypeScript convention. And to find out, well, it has to be, because interface is a TypeScript only thing. So everything in here, none of this is going to get transpiled into JavaScript. Yeah, so there you go. You can construct a point by assigning an object literal. After the assignment, x and y can't be changed. So object literals are just like this object syntax. X and y, 10 and 20, you try to change it, and you get a no. It's basically like a constant. You know what we should do is we should do this. So we're going to say, we're going to get up here, Q out of this, we're going to touch a read-only interface. And we're going to see exactly what that ends up looking like. Right, so you've got this point. We create a new point. Let p1 point 1 of type point interface point equal an object x of 1, y of 0, and then we try to say point 1 dot x is equal to 2, for example. Immediately it says cannot assign x because it's read-only property. If we try to change these, so this would be read-only.ts, read-only.js, it's not going to compile. First, oh, it does. Did I do that right? Read-only interface. Oh, I haven't saved it. Okay, so now we try and it errors, right? And the error is cannot assign x because it's a read-only property. So let's go ahead and not do that, and instead we'll just console log point 1, right? All the linting errors go away, compilation occurs as expected, and we've got x of 1, y of 1. Now, if we open up read-only.js, we just see point 1, x is equal to 1, y is equal to 0, and then we console log that. Well, guess what? If we're in the JavaScript, right, which you shouldn't modify JavaScript files that are generated from TypeScript using TSC, the TypeScript compiler. But we're going to do it for demonstration purposes. Point 1.x is equal to 2. Well, in JavaScript, that's totally fine. Right? So now if we just do node read only.js, look, now we have x is 2. And nowhere in here do you see the read only keyword, right? So the JavaScript is not special at all. Now, if in the next version of JavaScript that they released, you could somehow specify in an object literal read only here, then you would set your target transpilation to, say it's ES7 or whatever, and then it would understand to put that read only keyword before X here by way of the transpilation logic that the TypeScript has written. We're not going to be worried about any of that. So there you have it. That is read-only. We can see the keywords and the interface here. In the read-only JavaScript, we see no interface and no read-only. Test 2. Yep, I see that. I see that. Okay, so there you go. So we are 3 hours in. I'm gonna go for about 9 more minutes, and then we're gonna call. Well, maybe I'll finish. I might finish the chapter. We'll see. You can construct a point by assigning an object literal. Yeah. Read only versus const. The easiest way to remember whether to use read only or const is to ask whether you're using it on a variable or a property. Variables use const. Properties use read only. Const is in ES6. Read only isn't in ES6. Excess property checks. In our first example, using interfaces, TypeScript lets us pass size as a number, label as a string, to something that only expected label string. We also learned about optional properties and how they're useful when describing so-called option bags. Here, combining the two natively would allow an error to sneak in. For example, taking our last example using create square. Color width, we take in square config and we return color and area, and then color with an OUR is red. Notice the argument color instead of color. In plain JavaScript, this sort of thing fails silently. Okay. You could argue that the program is correctly typed, since width property are compatible. There's no color property present, and no extra color property is insignificant. Right, and the extra color property is insignificant. However, TypeScript takes the stance that there's probably a bug in this code. Object literals get special treatment and undergo excess property checking when assigning them to other variables or passing them as arguments. If an object literal has any properties that the target type does not have, you'll get an error. Object literal may only specify known properties, but color does not exist. I like that. Getting around these checks is really simple. The easiest method is just to use type assertion. So say create square with opacity as square config. Right, and then it's just like, hey, this object, even though it doesn't match this square config interface, we're just going to say that it does. However, a better approach might be to add a string index signature if you're sure that the object can have some extra properties. So this is important. A string index signature. So this is an index signature. Any prop name can be a string, and that's okay. if you're sure that the object can have extra properties and are used in some special way. If square config can have color and width properties with the above types, but it could also have any number of other properties, then we could, properties that are strings, then we could define it as this. Well, the prop name is a string and the type is any. We'll discuss index signatures in a bit, but here's what we're saying. A square config can have any number of properties. As long as they aren't color or width, their types don't matter. That's what the any does. One final way to get around these checks, which might be a bit surprising, is to assign the object to another variable. Since square options won't undergo access property checks, the compiler won't give you an error. So we let square options. So we, instead of just passing it in to create square, because we're not specifying the type on square options here to be a requirement of that interface, then it doesn't really matter, I guess. The above workaround will work as long as you don't have a common property between square options and square config. Okay. In this example, it was the property width. It will, however, fail if the variable does not have any common object property. Okay, that is really weird. Like, that seems undesirable. If you were writing code, I might have to play with that next time. Keep in mind, for simple code above, you probably shouldn't be trying to get around these checks. Agreed. For more complex object literals that have methods and hold state, you might need to keep these techniques in mind. Understood, but a majority of excess property errors are actually bugs. That means if you're running into excess property checking problems for something like option bags, you might need to revise some of your type declarations. In this instance, if it's okay to pass an object with both a color and a color property to create square, you should fix up the definition of square config to reflect that. Yep. Function types. So interfaces are capable of describing a wide range of shapes that JavaScript objects can take. In addition to describing object with properties, interfaces are also capable of describing function types. To describe a function type with an interface, we give the interface a call signature. This is like a function declaration with only the parameter list and the given return type. Each parameter in the parameter list requires both name and type. So this is common in interfaces in other languages. So basically, we surround, so we have an interface called search_func, open up the scope, and then this is a method. The fact that we put it in parens. Test3, I see ya. See ya on test3. The source is going to be a string, and the substring is going to be a string. Those are arguments into the function, and then we've got a Boolean. So once defined, we can use this function type interface like we would other interfaces. Here's how you can create a variable of a function type and assign it a function value in the same type. So we've got a variable declared in the let scope called mySearch, and it's going to be an interface of search function. Well, as such, it's required to have a function that takes in source string and substring string, type string, that is. So source type string and substring type string. And it returns a Boolean. And here, result, we search. So search on a string is going to return, I don't exactly remember. So we're going to look up mdn string search. So search method executes a search for a match. Return value, the index of the first match between the regular expression and the given string, if not found, -1. So notice how we didn't tell it Boolean here. It's going to say, for function types to correctly type check, the name of the parameters do not need to match, right? We could have, for example, in the above example like this. So I'm actually curious about this. So we're gonna do this. We're going to exit out of this. We're gonna make or touch a file called function interface.ts, and we'll mess with that. So we're going to have an interface of function interface, and it's going to take a function. It's going to take in source as a number. We'll say sync as a number, and it's going to return a Boolean, right? That's all it does. And then we're just going to have my function equal to a function that satisfies this. So like it said, you don't have to have the parameters passed in match, but the type does need to match. So we'll do that. And then sync will be a number, and we're not going to return a type. And then we're just going to return from this a -1. Okay. And of course we should make this let. In fact, maybe we can just const it, right? No reason to change that function. And then we're just going to call my function. We're going to pass in 1, 2. We should probably close those off. So I'm going to TypeScript compile function interface and node function interface. Okay, and we get an error. Sorry. I tried to run node on a TypeScript file, which is always a mistake. So we'll run it on the JavaScript file, and everything looked to be fine. So now we will console log my function. Okay, so even though we didn't specify a Boolean here, didn't mean Boolean. Oh yeah, this should be. Oh, that's weird that worked. Oh, hang on. Let me look at this. Okay, I needed to do this, so I say let my function be a type of function interface, and then my function is going to be equal to that, and we're going to return false. Right, so now if we get rid of that, because it's returning false, the linting and the compilation work, but if I were to return, say I want a number instead, we'd error out and be like, hey, you're not matching the Boolean. Also, if we were to return a number here, it would error out saying number is not assignable to type Boolean. Can you still, okay, so if we were to const that, this would fail. Let's get this passing real quick first. So false, Boolean, everything's good. If I were to const this, we would see, hey, constant means my function is not editable. Well, here, I am setting my function equal to something else. What I might be able to do would be something like this. There. And then I could have a const on my function. So I say const my function of type function interface is going to be equal to this function. And then down below here, if I tried to change my function to be something else, it would then error out and say, hey, my function can't assign to my function because it is a constant. It does make sense. I agree. So there you go. And that's how you can get away with const function expression declarations in TypeScript. There's so much more left. I need to call it quits here. So we are going to leave a note in a README that we're about to create. So inside of interfaces, we're going to touch readme.md. Observation about the stream: it appears that whenever the video has to buffer, it doesn't jump back to the most live stream. Yeah, likely it gets further and further behind. So I think the delay in me seeing chat update in the stream is because I'm technically a few seconds behind. Probably not something you can fix on your end. Not necessarily true. I'm going to check my bit rates. I'm going to check and see if the buffering is a continuous problem. Right now I'm streaming at full resolution. I can downgrade my resolution to lower the bit rate, and I can also switch to, I think I can shorten the window of the stream to be more real time. So I'll mess with some stuff on my end. I did notice a drop in participation when I increased my stream quality, so it might be buffering for a lot of people. Unfortunately, the tools don't give me any way to know if that's happening, so I rely on chat for that. All right, so in the README, we are going to say interfaces, and then we're going to say where we left off. Yeah, yep, please do. I would appreciate you keeping me up to date on that. So we left off. We're going to do a link. I always have to look this up. So in Markdown, a URL. Is it? Okay. URL is an email. Square bracket first. Square bracket, then this, and this becomes the link. And we will say function types. And then I guess we'll just put like a date on October 1st/2nd, because midnight. This is where we left off. And we'll do a get status here, and we'll get add interfaces. And you know what? I actually want to move interfaces readme here. Get status and get add interfaces readme, readme.md and readme. So now we've got what we want. And get commit beginning the interfaces section, left off on function types. And then real quick, see if I have access to my GitHub. I don't. I'll log in. So this code will go up on GitHub. I'll link it in the description and anywhere else I put the video. But that's it for now. So next time we're going to pick up on function types. Probably going to be streaming on maybe on Thursday night and then maybe on Friday night. We'll see about the weekend as that time progresses. So until next time, thanks for tuning in, and I guess just keep learning TypeScript. See ya.